Made for a very interesting time. All right, y equals the inverse secant of 5s. I'm going to change this to x because 5 and s just look too similar, so I'm just going to make it x instead.
Good plan.
All right, so inverse secant, and I get there eventually, is 1 over x, so in this case it would be 5x times the square root of x squared, so 5x squared minus 1. But it's also a chain rule, so what do I need to multiply by?
5.
So the 5 on top and the 5 on the bottom cancel, so I end up with 1 over x times the square root of 25x squared minus 1. And that's it.
How would you feel if I told you that you forgot your closing parentheses on the 5x squared?
You're not getting a cookie point for that.
Oh, I know. It's just, I didn't want Virginia to be confused.
She'll defer it back to you. Y equals the inverse cotangent of the square root of t. Alright, so tangent and cotangents are the easy ones, in my personal opinion. So, I guess I should also write y prime up here. What would the derivative of this be?
Negative 1 over 1 plus the square root of t squared.
Yep. Times chain rule.
1/2 t to the negative 1/2.
So, when I redo this, this square root of t squared is just going to become t. I'm going to put this 2 and this on the bottom. So I'm going to have negative 1 over 1 plus t times this other stuff. So I'm going to put that in parentheses. So times 2 times the square root of t. And just because I don't like the order that that's in, I'm going to do negative 1 over 2 times 1 plus t times the square root of t for the answer. Because I think that looks nicer than the 2 being randomly thrown in the middle.
I agree.
All right, and then the last step in this section is to find the equation for the tangent to the graph of y at the indicated point. So 24, y equals the inverse tangent of x squared, and x equals 1. So what do I need to find first? I'm trying to find the equation of the tangent line.
You have to find the slope, which you have to find the derivative of the thing.
Correct. Derivative first to find slope. What would the derivative of this be?
One over 1 plus x squared squared.
X squared squared. Sometimes I just go ahead and write it as x to the 4th, but just for the sake of seeing it written out, it's probably better to do it this way.
Times 2x.
Yep. Chain rules times 2x. So I end up with 2x over 1 plus x to the 4th. And then evaluated for x equals 1. So when x is 1, what do I get?
That's 2 times 1 over 1.
So this is my, I don't know why I just boxed that. That's the slope. Now, I have slope, but I need a point. How do I find the point?
Plug in 1 for x.
Plug in 1 for x. So, inverse tangent of 1 squared. Radian mode. Okay. Write that on here for Virginia. Radian mode.
So the squared goes on the 1.
Yes, so just inverse tangent of 1.
Okay. Inverse tangent of 1 squared is different from the inverse tangent of 1. So I guess it just thinks that the squared goes on the whole thing. Anywho, so how far out do you want me to go with that?
Let's just say 3.
Okay. 0.785.
Alright, so the point we're using is 1 and 0.785 for our point. And we have a slope. So now y minus 0.785 equals 1 times x minus 1. So I would have y equals x minus 0.215. And that would be the equation of the tangent line. And it doesn't ask us for the normal in this section, which is nice, because you never know. Okay, that will be it. Problems. 1, 5, 11, 13, 15, 19, and 25.
One thing that you gotta love about math teachers is that they always give you all their problems.
It's true. I do have a lot of problems.
Dump them on
7 books
students.
worth of them, to be exact. Or,
Oof.
well, technically I have more than that because I got all those extra AP books down there. Big oof. Yeah, it's fine. Bye, Virginia.